This is Daniel Olson answering quiz question number 1. What are the basic control modes? There are 4 basic control modes: the proportional control, proportional integral control, proportional derivative control, proportional integral derivative control. And we'll go through each of these. First and most simple control mode is proportional control. It produces an output signal that is proportional to the error. It has one adjustable parameter, which is called the control gain. The variable symbol for that is K sub C. The time domain model is P equals K sub C times the error plus P sub S. P is the output signal from the controller. K sub C again is the proportional gain. E is the error, which is the difference between the set point and the measured variable. And P sub S is the steady state output from the controller, which is basically a constant. It's also known as your bias when your error is set at 0. P sub C is what the value is of your controller. The transfer function for the proportional control is P of S over E of S, which is equal to your K sub C, which is your controller gain. This is the most simple control mode of the 4. It is used in industry, but not as common as some of the others. Second control mode is proportional integral control. It produces an output signal that eliminates accumulated error. It has 2 adjustable parameters. Again, the controller gain in addition to the integral of time, which is tau sub I. The time domain model, as you can see below, is the same as the proportional controller, but it has the addition of the integral control mode to it, which is K sub C over tau sub I times the integral of the error with respect to time. Again, it has the same variables in the equation that we discussed with the proportional control mode, with the addition of the tau sub I, which is the integral time, one of the adjustable parameters. The transfer function is P of S over the error of S, which is in your Laplace domain, equals the controller gain K sub C times the quantity of 1 plus 1 over tau sub I times S. This again is used in industry, but not as often as the next control mode, or the last control mode that we'll see. The proportional derivative control is the 3rd control mode that we'll look over this semester, we saw last semester. It produces an output signal that responds to the rate of change of the error. It again has 2 adjustable parameters, the controller gain, and this time it's the derivative time, which is denoted by tau sub D. The time domain model, as you can see in the blue box here, has what we found on the first control mode, the proportional control, with the addition of this section here, which is your controller gain K sub C times your derivative time tau sub D times the change of error with respect to time. Again, only new thing here is the derivative time tau sub D. That's the only variable change here from the proportional control. Transfer function, as you can see, is the controller gain times the quantity of 1 plus the derivative time tau sub D times S. Our last control mode, which is used most common in industry, is a combination of the 3 previous modes that we saw. It has 3 adjustable parameters: the controller gain, the integral time, and the derivative time. Again, as you can see, the time domain model shows the summation of the proportional, the integral, and the derivative control modes. Again, the transfer function also shows the combination of each of those control modes as well.